Thanks, Murad. So we'll continue here with the continuation from the earlier demonstration on the 5G setup, but the focus here is around EVPN and service automation, and also to do assurance with OAM. I'm joined here with Hu Chen from CTE and myself, Sujay, here from Cisco. So we kind of orchestrated and demonstrated this test at the Berlin hot staging, and the concept is to how to create or ensure that an end-to-end service health is beyond the control plane verification, right? How can you enable Ethernet CFM, where you could do proactive OAM monitoring, which is to do continuity check messages, the health message, health of a layer 2 VPN service, measure the delay or the loss, and then configure these OAM sessions across your EVPN endpoints. So the target here is to maintain the maintenance for the endpoints using MEPS, and then a traffic class using priority 6, which is like a production-like deployment. And then using telemetry and assurance is to collect these metrics through the data and to monitor these service level KPIs, measure the delay loss and continuity metrics. The outcome of this overall test was to show the real-time visibility into service performance, to do faster detection and isolation of issues. When there is a continuity check fails, then what is the health of the VPN service, although your VPN is configured and the layer 2 VPNs are up, and then improve operational confidence in the multi-vendor EVPN deployments. So the goal has been also to describe where it is essential for the operators, which is to provide them the visibility to control plane status. L2 VPN or EVPNs, as I said earlier, may show you up as up, but it'll still experience some issues, which is related to packet loss or latency spikes, intermittent instability. But with proactive OAM, right, which is operational administration and maintenance, it enables to do continuous performance monitoring. Although the routers have the capability to set up the CFM maps and the CFM peers, it will allow you to detect the early degradation of a service. And then with automation and orchestration, you could ensure that your EVPN ELAN based service over SRv6, a certain flex algo, which is a best effort path or a low latency path, can be used on the locators to determine the orchestration between your endpoints. Now in this test, we verified that the EVPN MAC address are learning across all the nodes on the SRv6. I'll go back to show you on the same topology service that was used. In this, the same topology that we used in the 5G deployment, we only focused to use the layer 2 VPN deployment. And the layer 2 VPN was actually part of only the SRv6 domain in the ISIS level 1 across multi-vendor nodes. So the orchestration was done and the automation between HP, ZTE, Cisco nodes to form a layer 2 VPN ELAN service over SRv6. So we created the layer 3 VPN and then the EVPN ELAN for ECPRI connection. So this is where today the topology that we had, we discovered this through crosswork, we orchestrate them through crosswork, and then through crosswork assurance, we collect the telemetry to show between service assurance and endpoints. So I'll quickly switch to the demo part here. Yeah, so we are using the same topology here, in this case, between those two endpoints, between ZTE and Cisco and HPE. And here is the assurance level parameters that we are collecting for layer 2 VPN across different metrics, right? So this is to say the SLA across the EVPN endpoints, the latency and SLA assurance between ZTE 6 and Cisco 250, which are one of the two nodes part of the EVPN ELAN service. And then to determine what is the latency between those overall service assurance characteristics. We also determine the service assurance per class, the L2 VPN service assurance per class of the service, and to determine the L2 VPN telemetry statistics. See, overall, to determine this, I'll also quickly switch to the CLI here, in this case. Is between two nodes on Cisco 215, that is to show between the EVPN ELAN VPN ID max that is being learned. Yeah, so these are all the MAC addresses that we are learning across the two endpoints when this is orchestrated across the service. And then we are also determining them to show between what is the SRe statistics, which is either it is kind of configured, but now it's we do some issues. We are seeing the CFM is failed due to the connection, but we'll also look at the EVPN. In bridge domain details. Let's check here. Yeah. So we created one EVPN ELAN service across these two endpoints, and we also kind of collect them both to the orchestration and assurance between those two endpoints and connectivity details. On the ZTE side, Shen, if you want to go through your.
Yes. For example, in ZT side, we can see the layer 2 EVPN MAC by this command. We can see this MAC is from Cisco side, and we will send the CFM packets from our side to remote MAC. Okay. CFM PO. One is this instance.
So show.
CFM and PO.
You want to use that graph?
One. Okay. In this side, we can see we send a CFM packet periodically, and Cisco will measure the latency for the CFM packet. Okay, that's all in this side.
Yeah.
We can see.
So the same configs, when we try to orchestrate, it is orchestration on the both layer of endpoints, right? So when we looked at the configuration also, it is shown on N2 VPN that we kind of orchestrated between both Cisco and ZTE, which is on the bridge domain 11 and EVI 11, and for ZTE, can you show the showrunning config?
This is the ZT side as segment routing version 6 EVPN VPS configuration. This CFM configuration. We will enable CFM in the layer 2 VPN user side client interface.
Yes, great. So both the sides, when the orchestration is done, and then on showrun CFM, for the deployment of the config. Yeah, so the same set of the CFM config that is enabled, it's orchestrated, and then the same set of the endpoints. So here we are kind of forming the RD auto, import and export across the same endpoints, and then using the unicast and the SRv6 locator, which is main in this case. So all this data that we have orchestrated is also available in the crossroad here for the topology screen, where we kind of use across the same VPN services and across the endpoints to show between all the FlexAlgo, which is the locator main, or the FlexAlgo 128. And then this node information is propagated through the service. And then for every service in the details, we can look at the interfaces, no interfaces, the links, and then the links that are advertised or collected between IPv6 L1 domain, because as we showed in the topology, this is purely an L1 domain connectivity on the network. So we have some snapshots here as part of the result, the OAM output. And then this was the overall test procedure that collected between preparing for the IETF L2NM EVPN service, commissioning of the service, and then enabling the EVPN config plus OAM, and then visualizing the EVPN service endpoints, and then running the end-to-end assurance test across those endpoints. Yep, so I think we looked at the live demo. Thank you very much for this.